So this is the agenda for today. It's kind of a lot of details, so we'll try and get through them quickly so you can ask your questions and go on with your day. So let's start with some high level, common mistakes RF engineers or basically any engineers getting into RF can make during, their layout phase. Definitely RF is a journey and there's definitely lots of prototyping that happens. So try and take what you can from this webinar and presentation and our design guides and see, help you hopefully improve your journey. So, you want to make sure that, of course, you match impedance across the RF components. If you don't, you can get reflections and signal loss. So, the other kind of issue is just when you route your RF signal paths, avoid the sharp bends, unnecessary vias that I could say are in the way. Inconsistent, trace widths can all lead to signal distortions. Via design is a key thing. Using strategies like laser drill vias or back drilling can help reduce any long stubs. And then component placement is key. So you don't want to make the mistake of placing components without considering your return paths and current flow. And then don't make the mistake of creating unintended ground loops and split ground planes. And of course, introduce noise and cause unpredicted circuit behavior. So impedance mismatches are often caused by poor layout decisions. So if you look at a few factors that can introduce discontinuities in the signal path, using incorrect trace widths without considering target impedance values, abrupt trace width changes during routing, ignoring copper thicknesses and dielectric heights in impedance calculations. That's an easy consideration. Um, Knowing what your solder mask thickness is post manufacturing, I think is a nice little nugget. So if you get a cross section of your board after manufacturing, you can understand your model a little bit better. What was the thickest of the solder mask and the copper weights and the dielectric press out thicknesses, and you can feed that back into, your own models and information, leading to continuous improvement. I think that's a key point here, not necessarily mentioned. And so, yeah, so these are some of the key things.